Hello and welcome to Twist List. Today we are looking at 10 insane experimental helicopters from history. Practical helicopters are relatively new on the aviation scene, only coming into their own after World War II. But in that time, intrepid engineers have often tried to improve on these flying machines, creating a variety of weird and outlandish machines. At number 10 we have Sikorsky Xwing. Famous helicopter manufacturer Sikorsky came the closest to giving the world a real version of the X-Wing fighter from Star Wars. In the mid-1970s, Sikorsky began playing with experimental helicopter designs, combining new power plants with leading aerodynamics. The key airframe for these experiments was the S-72 Rotor Systems research aircraft. Originally, the S-72 just tested out the possibilities of a mixed airplane/helicopter design, but in the 80s, the government provided funding for the X-Wing modification of the S-72. At first glance, the X-Wing looked like a normal helicopter, albeit one with very thick rotor blades and jet engines strapped to the sides of the fuselage. On takeoff, the rotor would spin just like a normal helicopter, allowing the X-Wing to take off vertically. The rotors were unusual in that they did not rely on changing the pitch of the blade to generate lift. Rather, they used a complex compressed air system that bled air from the engines and blew it over the rotor tips, generating extra lift. Once in flight, the rotors would lock in place, acting like normal airplane wings. When the X-Wing transitioned to normal flight, it would fly like an airplane since the big rotors would give enough lift for the airframe, and the jet engines would give forward thrust. Unfortunately for Sikorsky, the project quickly ran over budget. The government poured $100 million into the project before it even had the X-Wing rotors attached to the airframe. Sikorsky ran 3 test flights of the airframe without the rotors, but the completed X-Wing never got off the ground before the Air Force pulled the plug. The 9th spot on the list is occupied by Percival P Dot 74. During World War II, German engineers drew up various plans for bizarre helicopters and airplanes with the odd propulsion technique of tip-jet rotors. Normal helicopters have rotors that connect to an engine inside the airframe. Tip-jet rotors move the propulsion to the ends of the rotors. Usually, engineers put jet engines or ramjets at the rotor tips to spin the rotors extremely fast. In the 1950s, the British tried to get into the game of experimental helicopters with the unusual Percival P Dot 74. Unlike other tip-jet systems, the P Dot 74 used engines mounted inside the fuselage. 2 gas generators sat in the middle of the fuselage. A complex set of tubes moved the gas to the edges of the rotors, where the gas expelled through specially designed ejectors. The system had the advantage of producing much less torque than normal helicopters, meaning that the P Dot 74 only needed a small tail rotor. That is why it looked kind of odd and childish. As unique as the design was, it was not effective at all. Since the gas pipes ran through the middle of the passenger cabin, a flight in the P Dot 74 would not have been pleasant. If it could even get off the ground, that is. Percival diligently tried to get their helicopter airborne, but it stubbornly refused to lift off. The gas ejection system just did not give enough thrust to lift the bulky airframe. Engineers tried their best to redesign the helicopter, but the industry moved on without them, and the P Dot 74 ended up a dead end. Number 8 on our list is Hughes XH17. One of the most common uses of helicopters is as flying cranes, lifting heavy and oversized loads to places inaccessible by conventional airplanes. In 1952, the Hughes Aircraft Company designed their first helicopter, the XH17. At the time, the XH17 was the largest helicopter in the world, with a gigantic, 36-meter, 120 feet, rotor system. The XH17 used an unusual tip-jet system. 2 engines in the fuselage fed bleed air through the rotors and into tip jets. Unlike the P Dot 74, the hot air mixed with fuel and then ignited, meaning that the XH17 had small jet engines at the end of the rotors. Other than the weird propulsion system, the XH17 was a Frankenstein's monster of parts from other airplanes. To cut down on production costs, Hughes used a variety of World War II planes to make the airframe. The cockpit came from a CG-15 glider, the undercarriage came from a B-25 bomber, and the big fuel tank came from a B-29 bomber. When testing commenced, the XH-17 was actually a frightening sight. Flames surged from the jet engines on the rotor tips, and the constant combustion sounded like 1,000 artillery shells going off, according to one newspaper. People up to 13 kilometers, 8 miles, away could hear the helicopter when it started up. During testing, the XH17 revealed that it had an extremely limited range of only about 60 kilometers, 37 miles, and had thrust issues. Testing occurred sporadically for 3 years until Hughes realized that the helicopter would never be an effective system. At number 7 we have Sikorsky X2. As impressive as helicopters are, their biggest limitation is speed. Helicopters are not very fast, but their flexibility makes up for that limitation. Not content with slow-moving helicopters, Sikorsky embarked on a project to build the fastest helicopter in the world. Back in the 1970s, Sikorsky tried similar experiments with their XH-59A experimental helicopter, but the airframe vibrated so much that Sikorsky dropped the project. With new developments in computer flight control and composite airframe materials, Sikorsky had much more success with the X2. To get the most speed out of the X2, Sikorsky departed from the standard helicopter design. The two rotor blades spin opposite each other in a coaxial configuration, which in itself is not too unique. But instead of adding a tail rotor, Sikorsky placed a pusher propeller blade on the back for pure speed. Since the coaxial configuration negates torque effects, the X2 could completely rely on the pusher propeller for speed. In September 2010, the X2 reached 253 knots in level flight, an unofficial record for top speed of a conventional helicopter. The X2 was never meant for mass production, but it proved to be a highly successful technology demonstrator. With the lessons learned on the X2, Sikorsky is now working on designing a next-generation helicopter for the United States Army. Called the S-79 Raider, the prototype will replace the Army's aging fleet of observation helicopters using X2 technologies. Number 6 on the list is Kamath Car22. Russian and Soviet engineers have designed some of the largest and heaviest helicopters that the world has ever seen. In the 1950s, the Soviet Air Force invested in increasing the range of their helicopters to turn them into a workable transportation system. Standard practice was to get the helicopters up to operating altitude by towing them behind a transport, but that technique negated the advantage of being able to vertically take off. To increase the range of helicopters, the Kamath firm designed the Car-22, a fascinating composite aircraft. Essentially, the Car-22 was a conventional airplane with rotors attached to the tips of the wings. The two turboshaft engines drove both the puller propellers and the rotor system, requiring that Kamath design a complex and troublesome gearbox arrangement. Despite the constant troubles with the gearbox, the Car-22 was an impressive vehicle. It could carry 100 passengers and, during test flights, broke 8 world records in its weight class. The West got their first look at the Car-22 during the 1961 Victory Day Parade. Nothing in the West was comparable to the Car-22, and it was a huge shock for Western observers. However, the Car-22 suffered mechanical problems and had 2 fatal crashes within a year, wrecking 2 of the prototype airframes. Instead of giving Kamath the opportunity to fix the problems, the Soviets cancelled the project, and composite aircraft experiments became low priority for Soviet airplane firms. The 5th spot on the list is occupied by Ferry Jet Gyrodyne. The Jet Gyrodyne is an interesting combination of tip jets and an auto-gyro. To use a tip jet system, Ferry fitted their helicopter with gas burners at the edges of the rotors, propelling the rotor tips to high speed. That system was not incredibly unique among experimental helicopters, but Ferry also wanted their chopper to have the same capabilities as a fixed-wing aircraft. For that to happen, engineers created a system that would allow the rotor to slow down in flight. For takeoff, landing, and slow flight, the tip jets provided thrust for the rotor. But once the Jet Gyrodyne reached full speed and altitude, the thrust was slowly turned off in the rotor and transferred to the 2 pushed propellers. The rotor was not fixed in place and could rotate freely, providing small extra lift. In practice, the Jet Gyrodyne had no problems transferring from helicopter flight to conventional flight. The problem was getting it back into helicopter mode, which required the pilot to engage a complex set of operations with the clutch and the throttle. Unfortunately, that meant that the Jet Gyrodyne was extremely difficult to fly, which was one of the contributing factors to the project's end in 1961. Number 4 on the list is EMac. And number 2. Helicopter designs entered the aviation scene fairly early. Engineers grasped the basic principles of helicopter flight and used large parasol wings to offer the necessary lift for their machines. One of the key inventors of early helicopters was French aviation pioneer Etienne Emac's. Emac's first helicopter design failed to get off the ground, so he used a hydrogen balloon to get it to a good test altitude. Emac's second helicopter, accurately named the number 2, was much more successful. The machine was strange even by the standards of the day. For thrust, The number 2 had 4 engines driving multiple propellers and rotors. Shaped like a cross, each extremity had a rotor for upward lift. The rest of the airframe was covered in propeller blades spinning in various directions to offer horizontal stability to the craft. A pair of pusher propellers provided forward motion. In testing, the number 2 was relatively successful, capturing the world record for longest endurance flight of a helicopter both in time and distance. As exciting as the early successes were, EMac realized that his machine could only reach modest heights and continually tinkered with the design to get more altitude out of it. His further experiments were only slight improvements, and eventually EMac dropped the project and returned to hydrogen balloons for lift. At the third place we have the Lac HZ1. As helicopters became a bigger part of military strategy, commanders began looking for new uses of the technology. One of the biggest pushes was to create one-man helicopters that would allow soldiers to fly around the battlefield. To meet the need, a variety of American aviation companies designed outlandish and dangerous helicopters for use by the normal Army soldier. Out of all the designs, none were as dangerous looking as the Lac HZ1. The HZ1 had a small engine that drove 2 contra-rotating propellers. Just above the rotor system was a small platform for one man to stand on. To cut down on weight, the Lac did not place any sort of safety protection between the pilot and the rotor blades, meaning that any mistake would most likely send the poor soldier straight into the spinning rotor blades. Controls were rudimentary, and the pilots flew mostly by leaning in the direction that they wanted to go, making the HZ1 basically a helicopter Segway. Testing showed that the HZ1 had a top speed of 105 to 110 km per hour, 65 to 70 miles per hour. Surprisingly, testing went relatively smoothly. Some crashes did occur, but none ended in fatalities. The Army was on board for the HZ1, but changes in tactical doctrine made the HZ1 unnecessary, and the Army dropped the contract. At the second spot is Kamath Car56. The Soviet Union also wanted to get into the game of light, personal helicopters. Soviet commanders wanted a light helicopter that could be folded up to fit into a 50 cm, 20 in, diameter cylindrical container. With this portability, Kamath designed the Car56 to drop behind enemy lines or to be used by special forces. Soviet naval commanders also wanted the container to fit inside torpedo tubes so that submarines could send the little helicopter to operatives on beaches or near water. The helicopter was extremely sparse, and almost all the parts could fold up. Experiments with folding the rotor blades showed that they would need to detach from the main airframe, so in the final mock-up, the pilot attached them during assembly. The Car56 was extremely easy to put together and only required 10 minutes of assembly time. Unfortunately for Kamath, they could not find a suitable engine for the helicopter, and the project never proceeded beyond ground testing. And finally, at number 1, Mil V12. One of the things that the Soviet Union was best at was creating gigantic airplanes. So it's not surprising that the Soviet-designed Mil V12 holds the record for the largest helicopter ever produced, a record that has not been broken since the V-12's first flight in 1967. Mil began work on the monster helicopter to meet a Soviet Air Force requirement for a large, heavy-lift helicopter comparable in payload to the fixed-wing An-22 transport. Specifically, the Soviets wanted a helicopter that could carry missiles and other similar loads. The V-12 also would have had use in the civilian sector, specifically in lifting large loads to remote regions of Siberia that did not have airstrips long enough for big transport airplanes. To design the V-12, Mil borrowed the rotor system and power plant from their successful Mi-6 helicopter. The V-12 used 2 rotor systems, one on each side of the fuselage. The fuselage itself looked like a normal airplane, but used a unique double-decker configuration for the flight deck. A large vertical fin stabilized the helicopter, but the rotors rotated in opposite directions, negating any torque effects. Disaster struck on the first hover test in 1967, when the first V-12 lost power and crashed. Fortunately, the airframe was not totally destroyed, allowing Mil to repair it and continue testing. Despite impressive test results, by the time the V-12 was ready for production, the Soviet Air Force had made changes to its tactical doctrine that resulted in the V-12 becoming obsolete. Mil did not destroy the prototypes, and both still survive at air museums in Russia. Thanks for watching. If you enjoyed this video and would like to see more, then please hit the subscribe button.